This is Kartika, working as assistant professor in the department of ECE at SSM Institute of Engineering and Technology. Today I am going to discuss about the topic of brain chip technology. In this brain chip technology, we are going to see introduction, brain gate technology, brain gate empowering principles, hardware components, and the software required, then interface, final diagram. In introduction, the brain chip technology is a technology which involves communication based on neural activity which is generated by the brain. Brain chip technology implements the brain and the computer interface. Brain chips can enhance memory of a human, help to paralyzed patients, and are intended for military purpose. In brain gate technology is a technology that can be implemented in the brain. When it is implemented in the brain, the electrical signals is exchanged by the neurons within the brain. Those signals are sent to the brain and it executes the body movement. All signals are processed by a special software. These signals is sent to the computer and then computer is controlled by the patient. In brain gate empowering, the brain gate system is used to sense, transmit, analyze, and apply the language of the neurons. The system consists of sensors that it is implemented on the motor cortex of the brain, and the device analyzes the brain signals. The sensor consists of a tiny chips with 100 electrodes sensors. The principle used here is the brain signals are generated even though they are not sent to arms, legs, and hands. These signals are interpreted and transmitted into the cursor movement. The hardware requirements are the chip, the connector, the converter, the computer. First one is the chip. The chip is a 4 mm square silicon chip which is studded with 100 thin micro electrodes. Is embedded in the brain's primary motor cortex. The sensor detects tiny electrical signal which it is generated when the user imagines. It sends electromagnetic signature of the neurons. The brain chip provides fast and reliable connection between the brain of a severely disabled person and the personal computer. The second component is the connector. The signals from the brain is transmitted through the pedestal blood attached to the skull. The third component is the converter. In this converter, the signal travels to an amplifier where it is converted to the optical data and bounced by the fiber optic cable to a computer. The fourth component is the computer. In this computer, interface uses electrophysiological signals to control remote devices. The brain-computer interface, which are invasive, is programmable. The electrodes pick up the brain's electrical activity and carry it to the amplifier. These amplifiers amplify the signals up to 10 times and then pass the signals via analog to digital computer to a computer processing unit. The final step is the computer to process the EEG signal used in order to accomplish the task. The next one is what are the software required. The algorithms are written in C, Java, and MATLAB. The software algorithms analyze the electrical activity of the neurons and translate it into the control signal for using computer-based applications. So the main important function is going to implant the brain of severely disabled people. The brain implantation enhances the capability of the human organs and the sense. It has a significant role to play in the future genetic engineering field and the neuroscience. So the interface step, the easy and the least invasive method is used to device with a set of electrodes is known as the EEG, which is attached to the scalp of the patient. The electrodes can read brain signals. So this is a black diagram of brain chip technology. Here, the human brain signals are going for a signal acquisition process. In this process, the signals are converted into the digitized form. Those digitized signals are given into the signal processing unit. Finally, the commands are given into the PCI applications. So this is the architecture of brain and the computer interface unit. So same here, the brain signals are undergoing the process of EEG acquisition. The EEG acquisition, the digitized signals are produced. These signals are given in the unit of processing. After that, commands are given as the output of the patient actions. This is a like diagram for brain and computer interface architecture. And finally, the applications are navigate internet, play computer games, turn lights on and off, control televisions, and control robotic. Thank you.